Hollywood.
All right, we're back on making our handle. So we're going to put the threaded end down here. So again, the steps is I'm going to face this off. I'm going to center drill. I'm going to put my live center in to support it. Then I'm going to turn the diameter 1 3/8 back. At a 1/2 inch, I'm going to hold, this is going to be drilled or threaded for a 1/2 13. So I'm going to basically use that. So for the diameter of the 1/2 13 thread, so I have to be somewhere between 495 thousandths and 0.5 or 500 thousandths on my diameter when I'm finished. So let's go ahead and get this done. So again, I'm going to just touch off on the face. You can hear that chatter. What do you guys think that chatter's from?
Oh, you're going too fast.
I'm not going too fast on my feed.
It's wiggling too much.
Well, yeah, we're getting some vibration because the cutting tool is pushing off, so it's making some chatter, so harmonics. I call that the music of my people. So,
Oh, you know about harmonics?
Yeah, we have to deal with harmonics and machining as well. So there is my facing tool, okay? So I'm gonna get my carriage out of the way. We'll push my center drill up, lock my tailstock in place. Let's go ahead and drill that center. Again, I'm going about 2/3 up the taper on my center drill. Move that back. At this point, I'm going to shut that off for a second. Let's go ahead and get my drill chuck out of my tailstock, and we will go ahead and put my, what is it, dead center, live center?
Dead center.
Not my dead center.
Not the
My
dead
live
center.
What's the difference between the dead center and the live center?
Dead center. The dead center don't move.
The dead center doesn't rotate. The live center does. So I'm pushing this up and kind of into there. So it's kind of seated on the live center. I lock my tailstock in. I'm going to turn just a little bit to add some more tension, and then I will lock the spindle on the tailstock in place as well. All right, so I've faced it, I've center drilled. Now I'm going to come in and we will turn that diameter. So let's kind of back this off, make sure that my turning tool is in. I am using a TPG 431 triangular insert. The TPG 431 triangular positive. So the 431 is the 4 is the inscribed circle that's on there. The 31 refers to the actual radius of the cutting tool tip. So there's a lot of information there. So all right. So now I'm back to my 0. At this point, we know we're 1 inch. I got at least 100 thousandths, so or at least 500 thousandths to take off. So there's my 100 thousandths. So now, actually, before I do this, so I want to go my 1 3/8. So let's kind of, I'm going to establish my 0 for my 1 3/8 here. Okay, so there's 250. There's your 1/2 inch. 750. Nope, counting off wrong. So let's try it again. 750, 850, 950. There's 1 inch. 1 inch 100, 1 inch 200, 1 inch 300, 1 inch 375 is right there. Now, I'm going to come in and we will just dig in just so I can kind of establish that. So I'm just kind of digging in real quick so I know where that shoulder's going to be. Ordinarily, I wouldn't do that.
So you give an eyeball reference.
I have an eyeball reference. Now, ordinarily, I wouldn't do that. I'm kind of giving this and showing you there. Ordinarily, I would be picking up and being more precise. And the motion is to turn and then come out with the shoulder. But that gives me an idea of where my 1 3/8 is going to be. All right. So, and where I should stop. I also have, at this point, my 0 set here as well, so I will know. All right, let's go in. So I'm going to take 100 thousandths at a time. So my first 100,000s. You need to, if you're getting a bird's nest or something, turn the spindle off, get the chip out of there.
I have a question for you.
Sure.
What is the maximum you can cut at a time with this machine?
Okay, there's a lot of variables that go into that.
Depends on the material.
The material that we're using, the cutting tool that we're using, the speeds and feeds that we're doing. On this particular machine, I don't really take much more than 100,000ths. There are some times you can probably take a 1/4 of an inch.
I mean, I understand if you're working with hardened steel, but I mean this
No.
because the other. Yeah.
Typically on the lathe, 100 to 200,000ths is generally a pretty good depth of cut. So, all right, so here's the next 100,000ths. Again, I'm going to turn that off just to flick that out. Now, I haven't stopped to measure it yet. So this might be a time where you may want to go ahead and do that. So I still know I got 500,000, so I still have quite a bit more to go.
Half an inch.
So, okay. Okay. Okay, I will go ahead and measure at this point, so we'll see where we're at. So, and I should probably be somewhere around 700,000. I've removed about 300. So, I am at 683,000. So I got another 183 thousandths to go. So I'm going to take
a little over 5/8.
So a little over 5/8, yep. So I'm going to take another 100,000ths, I'll remeasure, and then I'll come back for my final. Yeah. Okay. Let's remeasure this.
0.568.
All right, so I got another 83 thousandths. So and we're almost there, and I'm going to take that. Remember, I want to be a little bit less than half an inch. So I took it about 2 thousandths deeper. So hopefully this should put me right around 498 thousandths of an inch. Come in, machine my shoulder. Hey, there you go. 497 thousandths on that diameter. So at this point, we can move this. So we're going to put a little chamfer on the corner here to help.
Help start the threads.
It will help start the threads. We call that a lead. So that lead that we put on there will, we're just kind of breaking the edge a little bit here. Just to help us with the lead. And I put about a 30-second, so somewhere between 30 to 50 thousandths, 45-degree chamfer on there. So there are some rules there that would be followed, but that will help give us a lead when we go to use the die to cut that thread with the die.